the sparks that changed the world. In a time before LEDs, before smartphones, even before electric fans, there was a world powered only by steam, oil lamps, and dreams. A world that was just beginning to understand the invisible force called electricity. But this new force had no map, no guide, no way to measure how much power it really had. People saw lights glow and motors spin, but no one could explain how much energy was being used or needed. That's when one man's quiet brilliance lit the path ahead. His name was James Watt, and the law he discovered would become one of the most powerful tools in all of electrical engineering. This is not just a formula, it's a story. The story of Watt's law. History, the man behind the measure. Let's travel back to 1781, in the misty hills of Scotland. Inside a small, smoky workshop filled with steam engines and copper wires, a man sat at his wooden desk. James Watt had already revolutionized the steam engine, but his curiosity had grown deeper. He was no longer just interested in motion, he wanted to know how much power it took to create that motion. How could we measure the strength of electricity? How do we know if a machine is powerful or weak? James Watt believed that this hidden force could be calculated, and so, he worked night after night. One evening, as rain poured outside his window, Watt connected the dots between pressure, flow, and the work done. From that moment, Watt's law was born, and it gave the world the ability to measure electrical power with accuracy. The unit of power was named after him, the Watt. Story, the secret equation of Watt-Nagar. In a faraway city called Watt-Nagar, energy flowed through the streets like water in pipes. Wires ran underground, glowing slightly with a blue pulse. Machines worked, but nobody really knew how much energy they were using. Some machines heated up, others flickered, and chaos grew. The people were scared, until three mysterious beings arrived. The first was Power, a brave hero with unstoppable energy. He had the ability to make things move, spin, and shine. But power was lost without help. The second was Voltage, a powerful but unpredictable force. He pushed energy with great pressure, but too much push could break things. The third was Current, a calm and loyal messenger. He carried the energy through wires like a river flowing through a city. Together, they formed the legendary team, P equals V multiply I. It means that power is born when voltage gives a push, and current carries that push forward. If either V or I is missing, power cannot exist. The people of Watt-Nagar cheered. Now they could control their machines, balance their energy, and live without fear. From then on, every engineer, electrician, and scientist remembered their names. This wasn't just a discovery, it was a law. Definition: Watt's law in simple words. Watt's law explains how much electrical power is used in a circuit. It tells us that the power, how much work is being done or energy used, is the result of two things. How strong the push is, called voltage. How much flow is happening, called current. So, power is simply the product of voltage and current. The stronger the push and the more the flow, the more power is consumed. It's like water in a pipe. The higher the pressure and the faster the flow, the more powerful the water blast will be. From the rainy streets of 1780 Scotland to the glowing circuits in your home today, Watt's law lives on. It powers your fan, your fridge, your phone, and your future. So the next time you switch something on, remember, P equals V times I. Power is never magic. It's a perfect team of pressure and flow. If this story helped you understand Watt's law in a way you'll never forget, like, share and subscribe to Electrical Online, where every formula becomes an unforgettable legend.